name's Larry Bennett. As Dr. Huff said, I work right across the street from the Eaton Innovation Center. It's one of 5 innovation centers that Eaton has. Unfortunately, Reagan Detroit was the original innovation center. We're talking about some details. A little bit about me. I've been with Eaton 32 years. I just say I don't look that old, but I am. I spent my first 12 years in aerospace, working for a few companies, most of which Eaton acquired. And then when I realized that if I wanted to stay with the aerospace, I'd have to move to Los Angeles or someplace else, and I wanted to stay in Southeast Michigan. So I jumped ship, went to a little automotive company. Actually, in between, I started my own company, whole new story. Went to an automotive company. I was there 2 weeks when Eaton bought them. So I stopped running from Eaton, I've been with them ever since. But in that process, I worked for very, very small companies, started my own company, and with Eaton, been in a very large company. So part of my talk today will be talking about what it's like to work in large companies that are publicly held versus small privately held companies as well. I have an aerospace engineering degree from Western Michigan University a long, long time ago. And then I have an MBA from Oakland University. And I'm on the Mechanical Engineering Advisory Board here at Lawrence Tech. A little bit about Eaton. Eaton is all about power management. If you look at any of the businesses that we're in, and there's a whole bunch of them we're covering, what we do is we manage power efficiently, reliably, and sustainably. That's our whole goal, and everything we do is around those 3 criteria of power management. It's really to look at what are the trends going on in the future is why we're in power management. All sorts of trends out there. When you look at the developing nations, the demand for energy, not only in developing nations, but everywhere, for buildings is going to go up, especially in developing nations. They're building office buildings everywhere, and the demand for energy and how you manage that to do it efficiently is going to grow considerably. Which is why we got into the LED lighting business a number of years ago. We recognize that LEDs draw 1/10 of the power of an incandescent light bulb, and we're seeing it now. Most new office buildings and old buildings are retrofitting their lighting systems with LEDs simply because of the cost savings and just in energy usage. The use of petroleum fuels, you'll see our industrial sector is all about vehicles. The use of petroleum fuels is going to rise, especially in developing nations. We can't do it with the vehicles and efficiencies that we have today. And then, of course, we have another business that is heavily into agriculture, supporting the equipment that runs agriculture. We're going to have 9 billion people projected by 2050. How are we going to feed them? We need equipment, we need processes that can grow food efficiently and effectively. So the financials, Eaton's about a $21 billion company. We serve a lot of different markets, but we divide it into 2 sectors. One is electrical, anything to do with electrical, managing of electricity, if you will, from where it's generated via a hydropower dam, nuclear power plant, or a coal-fired plant, all the way down to where you plug in a 110 outlet. We have components that manage that energy all the way through the system, and I'll talk a little bit more about those components in a minute. Then we have an industrial sector, really more in mechanical systems, in aerospace. It's all about hydraulics and flight controls and fuel controls for aircraft. In the industrial sector, hydraulics, or the hydraulics group, it's all about managing hydraulic systems for plants, assembly lines, or in earth moving equipment or any off-road equipment where hydraulics is used exclusively because of its power density capability. And then lastly, the part I'm in is the vehicle. It's commercial trucks, it's passenger cars. It's the smallest group. We're only about 16% of Eaton's revenue, but it's the original Eaton business. And it got started right here, actually over in Kalamazoo, Michigan, and has grown in Michigan ever since. So most people know Eaton as a vehicle company, but it's actually just the tip of the iceberg of what Eaton has. Diving in a little bit to what some of the products are. I talked about electrical sector coming from where the power is generated to where you plug in your devices here in the building. First, it's about power distribution and circuit protection. We make circuit breakers, fuses, and all sorts of equipment that manages the different circuits that are required and the systems that run in a building. We do a lot in power backup, especially for developing countries where you have roaming power outages. We make equipment that instantaneously kicks in, provides backup power so that your data centers and the equipment that can't go down for any period of time remain running. Lighting and security, we talked about that heavily into the LED business and security systems around lighting, especially in power loss. Control and automation, once the power is being distributed, now you gotta control how it works and how you monitor the devices that it's running on to make sure you don't get too excessive surges so you can manage that as you go. That's a big area that we're working on, is controls and managing that power effectively to the different circuits that you have. Hazardous, that's another big area for Eaton. We've developed a line of products that are really geared towards hazardous environment, whether it be a caustic area, a high temperature area, any place, especially industrial buildings where you're manufacturing, can be very hazardous conditions. You need to have the same level of power management, but how you harden those circuits and how you manage them is a very different story. And lastly, since we have all this componentry, all this capability, we have a whole nother business that actually works with architects, works with new buildings to design the entire electrical system that manages that building and install our components as we go. The other part of that surface is we often will provide a monitoring service of the building. We'll collect the data in real time. If we see anything getting out of whack, we can send a message to the facilities people and let them know, you have an air conditioning system that's starting to draw some excessive current. You might want to service it before it becomes a problem and breakdown. On the industrial side, again, with aerospace, automotive, truck, hydraulics, I'll go into each one of those. In aerospace, all of the electrical I talked about was all an acquisition. We didn't really develop that. We went on an acquisition spree. We can talk some details of that. Aerospace was also acquisition. I was part of that acquisition. We made hydraulic and fuel components and systems for commercial and military aircraft. And then through additional acquisitions of companies like Aeroquip and Vickers Aerospace, we've become one of the largest suppliers of hydraulic and fuel systems globally. So it's components such as fuel pumps, fuel flow and pressure management. It's in some areas injectors for the combustion cans on jet engines. But it's also hydraulics that control the flight surfaces, the landing gear, emergency backup. In aircraft, if you have a crack in a hydraulic line, the last thing you want to do is look for a place to pull over. So we have mechanical and monitoring systems that will switch from one hydraulic system to the other hydraulic system, obviously to keep the airplane in the air. Very important on military aircraft where the opportunity to lose a hydraulic system is pretty high. Fuel systems we talked about, and motion control, which is the aircraft ailerons on the gear and that sort of. In the hydraulics business, again, it's pumps, it's motors, it's control valves, it's monitoring systems, it's controlling motion in any way. It could involve clutches and brakes, things like that, and all the hoses that can be used in an industrial or an off-road system. We're one of Caterpillar's biggest suppliers of their hydraulics, as well as John Deere and others. Fairly big business. This one also, we had some internal capability, but in the 1980s, we bought some very large hydraulic companies to form Eaton Hydraulics. And lastly, we'll get into what I do. On the truck side, this was the original Eaton business. It was truck differentials and truck transmissions. For probably the last 70 years, we've enjoyed upwards of 80% of the line haul truck market for transmissions. We had manuals for years and years and years, but in the last 20 years, we've been working on automation of those manuals for a number of reasons. Foremost is you can get much better fuel economy if you're managing when the shifting occurs versus a driver. They tend to drive very inefficiently. That allows the fleet operator to save money, so he's all about doing that. But also happens is you don't need the skill set of a skilled driver anymore if the transmission is automated. That reduces their costs as well. On top of that, you save wear and tear. If you shift the transmission appropriately and govern the engine to tell it what to do so you can make that shift easily, you don't wear out clutches, you don't break shafts. It's a much more better way to operate your fleet and save money. On top of that, the automation enables a lot of other things which I'll talk about, which is where you can now start looking at what the infrastructure is telling you. Traffic lights today in a lot of areas broadcast what they're about to do, what their state is and how many seconds it is before they're going to turn yellow and red. It's all about this vehicle, VI, they call it vehicle to infrastructure communication. It's out there, but we're already putting in play with GPS. GPS is available on most city buses, on refuge trucks, on pickup and delivery, simply because the people who run those businesses want to know where those trucks are. So they're already GPS enabled. We can use that information to improve when the shifting occurs, how much acceleration you allow the driver to do, so that it's appropriate for the next 5 seconds or 10 seconds of what the truck's going to see. I can go into more detail there. That led us into the whole hybrid. City buses, refuge vehicles, pickup and delivery are perfect opportunities to put hybrid systems onto vehicles. It's all stop and start driving. The ability to recover energy on the stopping side of that and put it into a battery and then accelerate the vehicle using an electric motor is very, very efficient. The idea is now is to try and get it cost affordable. And I'll talk about some of the things we're doing to make that more affordable and decrease the payback time so more and more people buy them. We make engine valves and valve trains for large commercial diesel engines. That's lifters, rocker arms, engine valves, lash adjusters, anything that's in the valve train assembly. Doing a lot of things there to be able to allow the ability to change the valve duration, the open time, the amount that it opens on both sides of opening and closing, so that you can in real time dynamically vary the valve timing to get the maximum efficiency and performance out of the engine. I'll go into a little bit of detail there as well. And then on the electrical side, even though it's a vehicle product, we're getting heavily into power electronics. As the hybrids become more and more relevant and affordable, they're going to want to have a 12-volt system, they're going to want to have a 48-volt system, and they're going to want to have about a 600-volt system. And managing and doing all the power conversions and the inversions, D to C to DC conversions at those kind of currents and those kind of voltages requires a whole new generation of vehicle power electronic assemblies. Automotive, superchargers. We've been making superchargers for years and years and years. Really one of the only ones out there. It's a niche market. It's really traditionally has been for adding performance to a vehicle to make it a high performance vehicle. But with legislation, fuel economy and emissions getting tighter and tighter, we're looking at ways that we can actually make this a fuel economy play versus just a power and performance play. They're trying to downsize engines. They're trying to slow engines down, run them at a lower speed. In order to do that, you've got to be able to put more power into them, more air into them. As you now start to get into 3-cylinder, maybe 2-cylinder engines, a turbocharger really can't perform in that environment. There's too many pulses in the exhaust. Opening the door for something like a supercharger to really take hold, and we're doing a lot of development there to make that more affordable and a better performing device than it is today. More valve train stuff, very similar to what I talked about. We make differentials and torque control devices for both front and rear wheel vehicles. A lot of controls for automatic transmissions, fuel vapor. It's all about regulation on that one too. It's managing fuel vapor. When you fill up your vehicle, all that vapor that's being generated has to stay in the vehicle. It has to go to the charcoal canister. We make the valves to make sure that no vapor comes back out the pipe. In fact, that's the signal that tells your fuel fill nozzle to shut off. So when you're standing there waiting for your gas tank to fill and it shuts off. It's an Eaton device telling it to shut off. And then as the car is moving, you have a sealed tank, you're generating fuel vapors. We're managing those vapors to the carbon canister, but not allowing any liquid to leave the tank. All done mechanically today. A lot of advances now in trying to do that electronically and smarter, and being able to flatten out fuel tanks so we can get lower, better fuel economy vehicles, lower profile front ends. So a lot of work being done by that. We're doing that next door. So a little bit more about then my area. The reason I exist, Vehicle Technology Innovation, is a fancy name for research and development. Eaton is all about research and development. We recognize that research and development allows you to have products on the market that are different from what our competitors can provide. That adds more value to our customers, and they're more willing to pay a premium for those. So if you're number one and number two in your markets, your products don't become commodities, and it isn't a price war between you and your competitor. You offer something that's more value again, and they'll pay more for it. And that goes across all of our businesses. So we invest in a lot in R&D. We have 5 innovation centers globally. Again, one is right across the street from us where I work. We're all about patents. I think we have 10,000 active patents. I have no idea how many have been generated over the years and now become obsolete. So what are some of the vehicle technologies that we're working on right now? Most of this is across the street, but I also have a facility in Prague, in the Czech Republic, that's working on projects for the European region. Also a group in Pune, India, that's working on projects for the Asia Pacific market. We try to do regional projects that are for the region and in that region, because customer communication, working with customers is very, very important to be successful. So we have these vehicle technology innovation teams located globally to service those regions. I talked a little bit about transmissions. Government regulations are really starting to appear, city regulations, to where if you can make an all-electric bus or an all-electric refuse vehicle, something that runs a very short emission cycle, and you can charge it at night and have it run its duty cycle that day. If we can get that affordable, I guarantee most cities will ban internal combustion engines. They're already heavily limiting them right now, just because of the pollution problem. In China, Beijing, Shanghai, they have already are paying subsidies for the fleet owners of these vehicles by pure electric vehicles, which is where we're initially involved in providing transmissions that takes the existing EV technologies, where you got this big electric motor, a single gear ratio to the rear wheels, and massive batteries. It's very inefficient, because electric motors, their peak efficiency is a very narrow RPM band. So the idea is to keep it in that RPM band, not let it wander outside of it. So we're working on automated 3- and 4-speed gearboxes that keep that engine running where it's supposed to be. Also doing the look-ahead thing I talked about, where understanding its environment, what's actually going on, knowing where it's at, how many people are on board, we can sense the weight of the vehicle, and give them an appropriate gear shift and electric motor speed that keeps it in its most efficient range. So very interesting work. It's going to happen in China when the DOE visits us quite often. When they found out that we were doing this for the China market, they immediately created some funds for us to do the exact same thing for the US market, specifically for port of calls, where you have these really old, nasty diesel engines unloading ships, running them up to a distribution parking lot where they go on line haul trucks and move away. Pollution's terrible in those areas. They would really like to eliminate and make that all electric infrastructure. We talked about internal combustion engines. They see the threat of all electric vehicles, so they're doing everything they can to improve the efficiency of the internal combustion engine. And like I said earlier, one of the biggest ways is to be able to dynamically change valve intake timing, duration, the amount of lift it has. If you can tune that on the fly and have full control of it, you really can improve the efficiency of an internal combustion engine. I'm talking maybe 10%. That's huge in most circles. So we're working on all sorts of valve train systems, both for commercial diesels and for passenger gasoline engines. We're in that torque business I talked about. One of the fun things, we're working on it right now. I hope to have this vehicle out within a month. But as we've gone for fuel economy, we've taken away rear-wheel drive vehicles and gone to front-wheel drive vehicles, which is great, but you also lose some maneuverability and performance control of a front-wheel drive over a rear-wheel drive. So the customers have really been looking at how can we take a front-wheel drive, be able to provide torque control side to side, so that if you get the vehicle into a yaw condition, especially on tight turns like this one here, you can still maintain control of the vehicle and not have it swing out on you. And you can do that simply by measuring and monitoring yaw of the vehicle and appropriately responding with yaw control. So this is a device. There are other competitors of this out there. We know it works. But again, to really be successful in business, you want to be the one that does it the least expensively and with the best performance. So we think we have a better mousetrap on how to do that. Building it next door. Certainly the modeling and simulation we've done shows that our torque vectoring device in green, which is the green vehicle, allows you to maintain much higher speeds on tighter corners than you can with traditional front-wheel drive systems. I talked about this one. Look ahead. This one is a very simple, watered-down version. It's just a software change to our electric vehicle transmissions and hybrid vehicle transmissions. But it's simply looking at GPS data, knowing what's coming up in the next 5 to 10 seconds, and then efficiently varying the amount of power being driven or being delivered by the engine versus the electric motor. By doing so, we've been able to demonstrate on plug-in hybrid, we have gasoline on board, an almost 23% fuel economy improvement, and we can reduce the size of the battery by about at least 20%, maybe 25%. And when you talk about hybrid vehicles, what's really holding them back is the cost and the maintenance of batteries. So anything you can do to reduce the size of that battery and still give it the same amount of life reduces the cost to acquire one of these vehicles and gives a better payback to the owners of these things. This is actually going to go in production shortly. Again, the internal combustion engine people fight back against this. They recognize that an internal combustion engine, gasoline engines maybe 35% thermal efficiency, a diesel is maybe 45% thermal efficiency. Where's the rest of efficiency going? It's going to heat right out the exhaust. Can you recover that heat and put